Okay, so last section we are looking at is 4.1, part 2. And the goal of this section is to solve triangles. So what it means to solve a triangle is basically to figure out how long is each side, how big is every angle. So there's 6 things that we have to know. 3 sides, 3 angles. Now, we're solving right triangles. So what do we already automatically know in every problem? There's a 90-degree angle. So there's one thing that we don't have to figure that out. In addition to the 90, I have to tell you a little bit more information for you to figure out the whole triangle. Okay, I couldn't just give you a triangle like this and say solve. You don't have anything to go off. Okay. So to solve that, there's, sorry, it's like scrolling at the same time. Okay, so to solve that, I need to give you 2 more pieces of information. I can either give you one of the angles and one of the sides. Doesn't matter which one, just one of the other angles and one of the other sides. Or I can just give you 2 sides. As long as you have that information, you can figure out everything else in the triangle. Okay, so any question on what you have to be given to figure out? Okay, so first thing we're going to do is we will make a sketch, because we got to be able to visualize what's opposite, what's adjacent. And the easiest way to do that is to take everything they give you and then make a diagram. Then off to the side of the diagram, we're going to make a table, and that's where we're going to put all our information. Okay, because it's going to be a lot of work we have to do. So it's easier if we just put all our answers in one spot, so it's nice and organized. All right, that's really pretty much it. So we're going to stick with using 3 trig functions today out of the 6. Well, let's just name what the 6 are. Okay, what are the first 3 trig functions that we usually put like these on the left side? Yeah.
Sine, cosine, and tangent.
Yeah, sine, cosine, and tangent. And what are the other 3? Yeah.
Cosecant, secant, cotangent.
Cosecant, secant, and cotangent. We only need to use 3 of them to do what we're going to do today. Which 3 do you think we're going to stick with? Yeah.
Sine, cosine, tangent.
Why would we stick with those 3?
Do it on a calculator.
Yeah, because we have buttons when we have to type stuff in on the calculator. We have buttons for sine, cosine, and tangent. If we try to use the other 3, then we have to get into flipping things to use them. So we're going to stick with sine, cosine, and tangent. All right. So let's see if we can solve this problem. This is an example of the first type. I'm giving you a side, and I'm giving you an angle. And that's an angle in addition to the 90. You always know the 90, so that's good. Okay, so I've got my 2 things. What I'm going to do is make a table. I'm going to put the 3 sides in one column, and then I'm going to put the 3 angles in the other column. The angle at the bottom is always just going to be a 90. Okay, that's going to be the same in every question. Now what I want to do is turn that into a picture. Okay. Now when you draw a triangle, right, it doesn't matter like which way you have it face. all that matters is once you draw this, you put the labels in the right spots. Whether you want to flip your triangle and make it like that, that doesn't matter. Okay. So what are the names we use, or what are the symbols we use for the sides? Yeah?
Alpha and beta. No, see. I don't know. The lowercase English letters.
Yeah, the sides are always the lowercase English letters. So I would do A, B, and C. And then what's the name of the angle that's always across from A?
Alpha.
Alpha. And the angle that's always across from B?
Beta.
Beta. So that's the diagram you're going to use every time. Now fill in what you know. We know B is 2. So I'm just going to cross the B out, make that a 2. Or you could leave the B there if you want to be able to see what letter it was. So B is 2. Alpha is 40 degrees. And that's it. Those are the only 2 things I can fill in. Any question on the diagram? All right. Now, when you are solving a right triangle, you can find anything that you're missing in any order that you want. So I put boxes around everything you have to find. Does anybody see which one of these would be the quickest to find? Yeah?
Beta.
Yeah, beta is going to be very quick to find. And how much is beta? How much? 50. Yeah, because all the angles have to add up to 180. You already have 90 for the right angle. So the other 2 angles together have to make 90. Okay, so that's beta. Any question how we got beta? Okay. Now, when we solve for A and C, you have to pick one of these 2 angles to use to do it. Which angle do you think we should pick? Yeah?
40.
Why?
Because it's pair A we do not have yet.
I agree that we should use the 40, but there's another reason why I think we should use the 40, not the 50. Anyone have another idea of why we would want to stick with the 40? Yeah.
Because it has something adjacent to it?
It doesn't have to do with where it is. It doesn't have anything to do with placement. But there's another very good reason why you should stick with the 40. Yeah?
It's an even number.
So is 50.
Not sure.
Yeah. Doesn't have anything to do with being even or odd. Anyone have another guess?
Because it's by the base.
Well, that'd be like a position of it. It doesn't have anything to do with where it is.
Because you can go find it easy.
Yeah?
It's the one they give you.
Why would we want to stick with the one that was given?
Because you might make a mistake on the other angle.
Right. I know the 40 is right. Okay, it was given to me. I know the 50 is right. I mean, that was an easy one. We could do the math in our head. But if we had made a mistake and we got beta wrong, and then we use it, then everything we use it for is going to be wrong. Okay, so the point is, don't use something that you calculated to figure out something else. Only use what was given. So I'm going to circle the 2 things that we can use all the time. The 40 and the 2. Those are the 2 things we can use. Let's see if we can find A first. So the first thing we have to do is decide on a trig function. Everything is going to be from the perspective of the 40, which is over there. Let's label A and B as far as their position. Side A is in the what position in that triangle?
Opposite.
That's the opposite. Yep. And what about side B?
Adjacent.
That's adjacent. And side C? Hypotenuse. those are the labels for this triangle from the perspective of the 40. Okay, now we're finding A. What's the position of side A? Opposite. And what's the position of the side that we were given? Adjacent. So we're trying to find opposite, and we know the adjacent. There's only one trig function that has opposite and adjacent in it. Tangent. That's how you decide which trig function you're going to use. Look at the side that you want to know. Look at the side you already know. Figure out the names of those, the position of them. Opposite and adjacent. And then look up in your notes what trig function is opposite and adjacent. So you always start with the trig function. Leave room for your argument. That's what you're plugging into the tangent function. And on the other side, it's going to equal a fraction. Okay. What's the angle that we're using as our perspective for this problem?
40 degrees.
40 degrees. So the tangent of 40. And what's the definition of tangent?
Opposite divided by adjacent.
Opposite divided by adjacent. What side is opposite 40 here?
Side A.
Side A. What side is adjacent?
2 or side B.
The 2. So opposite is A, adjacent is 2. Opposite over adjacent. That's the equation that you have to set up. Right, now we just get A by itself. The only thing preventing A from being alone is 2. And how would we move that 2 to the other side? Yeah, multiply by 2. Times 2, that's gone. Times 2. And that's how long side A is. Okay, we're going to type that in. We're going to round it off. First of all, that's degrees. So if you're not in degrees, fix it. So you're in degrees. Right. We'll type in 2 tan 40. Okay, we're going to round that to 3 decimal places, so that's 1.678. Okay, you should have gotten 1.678. You notice how the line just kind of like jumped down on the screen? Yeah? Anybody see that? Okay.
It's in the video.
Yeah, it's in the video. Like, I undid it really quick, but it was right there. Like, I didn't draw it. All of a sudden, it just jumps, and it does it a lot. I don't know why it puts in lines like that. I'm gonna try to find out, but it's in the video, so maybe I'll send it to the company and they can figure it out. All right, so now we got to find C. Well, I know 2 of the sides. So what's the formula that you can use if you know 2 sides in a triangle and you want to get the third one? Yeah?
Pythagorean theorem.
Yeah, so you could use the Pythagorean theorem to find C. But why do you think I'm going to say that's not a good idea?
Because it's not nice numbers.
What about this number?
It's not a nice number.
What makes it not nice?
Because it's not a whole number.
Okay, so yeah, it is a decimal. And what else about that number? Besides the fact it's a decimal. Yeah?
It's rounded.
It's rounded. That's not an exact answer. Okay, so if you use something you rounded, it's going to mess up something else. And it might not even be right. We found that. So if it's wrong and we use it, C is automatically wrong. So don't use it. So let's find C. Same way we found A. Okay. What's the name of the side that we already know? Well, I'll say it this way. The side that was given. 2. And that's the
Side B.
Side B and the position of it?
Base.
Adjacent.
Adjacent. So the side that we know, excuse me, is adjacent, and I want to find C. What position is side C?
Hypotenuse.
Hypotenuse. I know the adjacent. I want hypotenuse. What trig function has adjacent and hypotenuse?
Cosine.
Cosine. Yep. So cosine. Leave room for the angle that you're going to fill in, and leave room for the fraction that goes on the other side. Hey, what's the angle that we're using? 40. We're using the 40. Yep. Cosine is adjacent over hypotenuse. How long is the adjacent?
2.
2. How long is the hypotenuse?
C.
C. Yep. So 2 over C. All right. It's a little bit different. This time the number is in the top of the fraction. Last time it was in the bottom. But you still start out the same way. Multiply each side by C. So that gives you C cosine 40 equals 2. It doesn't get the C by itself, but at least it got rid of the fraction. Now, how could I get that by itself?
Divided cosine 40.
Yep. I'm going to divide each side by the cosine of 40. Cosine 40 divided by cosine 40 is gone. C equals 2 divided by cosine 40. There's your answer. All right, let's do it again. 2 divided by cosine 40. What would that be rounded to 3 decimal places?
2.611.
2.611. Yep. Now, if you had extra time and you wanted to check if that's right, sure, try the Pythagorean theorem. See if 1.678 squared plus 2 squared, see if it equals 2.611 squared. Well, let's see.
Oh,
Did,
it doesn't. Oh. You're close, though.
you're close.
Oh, it's rounded, so.
Right, it's because it's rounded. We only rounded to 3 decimal places, so I wouldn't expect it to be accurate really past 2. Right? If you wanted more accuracy, you would have needed even more. But yeah, they both came out to like, that's 6.816 rounded, 6.817. Yeah, very close. Couple other things you can look at when you're done your problem. The biggest side should always match up with the biggest angle. The smallest side should always match up with the smallest angle. And then the medium side should match up with the medium. And that's how you solve the triangle. Now, look at what happened in this last one. We started with this. That was the original problem we set up. And we ended up with that. Right? And we did some work in the middle to get there. But does anyone see how you could go from this green box right to that one?
Swap the C and the cosine.
Right. So I'm going to use a trick. Whenever we have a letter in the bottom, I'm just going to take and swap those two things, and I'll be done. It'll get the letter by itself.
Oh.
Okay. And the reason why you can do that, well, that's what we just went through. You multiply both sides by C, and then divide by cosine 40. But that's going to happen every time, whenever you have a letter in the bottom. So if you had something like that, 5 equals 2 over x. The answer is 2/5. You can just swap the letter in the bottom with what's on the other side. That only works in this kind of setup. You got to have 3 things. Fraction on the right, and just a single number on the other side. All right. question on that? Okay, let's try this one. All right, so solve the triangle. It's the same type as the last one. Here's a side, here's an angle. Before I start doing any calculations, what do I always want to do with that information so I can see what's going on?
Scheduling.
Yeah, we'll make a sketch. So let's make a sketch.
2.
Okay, so A is 6, and just remember the diagram that we're using. And you use that same diagram for every problem. So A is 6. Angle across from A is alpha. What's alpha? We don't know. I don't care if we could figure it out easily. I don't want to do that here. So I got A, I got alpha. Okay. What's B? We don't know. What's the angle across from B? Beta, which is 20 degrees. These problems could be radians or degrees, but all the ones that we do, they will be degrees. And what about C? How much is that one? We don't know. Okay, so these are the two important pieces of information that we're going to use to figure everything else out. All right. What do we want to find first?
Alpha.
Let's find alpha. How much is it?
70.
70, yep. Because 70 plus 20 is 90, plus 90 is 180. Okay. Now we got to do B and C. Let's do C first. Okay, let's get that one. I have a choice. I could use the 70 or I could use the 20. Yeah, why do we use the 20?
Because we know it's true.
We know it's right. It was given. Okay, so let's find C. We got to figure out which trig function that we need. So to do that, we need to label the positions. Everything is from the 20. So what is side 6? What position?
Adjacent.
Well, that's adjacent. What about side B?
Opposite.
It's opposite. And side C?
Hypotenuse.
It's always an hypotenuse. Okay, so we're trying to find side C. That's the hypotenuse. And what's the side we were given? Where is the side we were given?
Right. 6.
And where it's adjacent. So we know adjacent. We want hypotenuse. Which trig function should you use?
Cosine.
Yes, cosine. Cosine of, that's not multiplication. Remember, that's a number that you're filling into the cosine function, and then the calculator is going to do some math. So cosine of some angle equals a fraction. Okay, what's my angle?
20.
20. And what's going to be the fraction on the other side?
6 over C.
6 over C. All right, this is going to fit into that shortcut we did last time. So what is C equal to?
6 over the cosine. 20.
Yep. All right, let's see what we get. 6 divided by cosine 20. And to 3 decimal places, what are we looking at?
6.35.
6.385. Okay. And what do we have left?
Opposite side.
What side?
B.
B. Yep. So now we got to find B. Okay, let's find B. All right. What position is side B?
Opposite.
Opposite. And what position is the side we were given?
Adjacent.
Adjacent. Opposite and adjacent. Which trig function has those two?
Tangent.
That's tangent. See, I just did it again. I drew that line. You're trying.
Maybe it's when you get too close to the
I
board.
don't know. Maybe I don't know. Maybe it's dirty or something. I gotta figure that out. It happens a lot. For a multi-$1,000 board. I don't want that to happen. I want it to work perfect. All right. So tangent of, now we need our angle. Okay, what's the angle?
20.
20 degrees. Opposite over adjacent.
B over 6.
B over 6. Now, you don't want to switch the 6 and the tangent 20. That's not going to get B by itself. What do we do to get the B alone here?
You just multiply 6 on both sides.
Just multiply by 6. 6's are gone. And that should be your answer for B. 6 times the tangent of 20. Okay, so 3 decimal places. What do we get?
2.184.
2.184. Yep. And that was B. 2.184. All right. So that's the type where they give you an angle and they give you a side to study. Any question on that type? Okay. So now the other type is if they give you 2 sides. So let's see what happens when we have that. Now in this type, you don't have any of the angles. So you're not going to be able to just add one of them up and subtract from 90 quickly. But there is something you can do this time that I'm okay with that I wasn't okay with before. What do you think? What do you think I'm okay with you doing this time? Yeah?
Using information you find.
No, I still don't ever want you to use something that you find because it could be wrong. Something else that I'm going to be okay with though, yeah? Yeah, why do you think I'm okay with using the Pythagorean theorem this time?
That's all we got.
Because what?
That's all we got.
What do you mean it's all we got?
Because you're given the 2 sides.
Yeah, we're given the 2 sides. You're not plugging anything into the theorem that you found. You found the 3 was given, the 2 was given. So it's solved for C. Okay. Solving for C. What's my formula going to look like?
A squared plus B squared equals C squared.
And then if you fill in those numbers.
9 plus 4.
So 3 squared plus 2 squared equals C squared.
Sorry.
Yep. And then you said 9 plus 4.
Yeah. 13.
So that's 13. And what do we do from both sides?
Remove both sides.
Yep. Now, in these kinds of problems, they will tell you you can round to 2 or 3 decimal places. Yesterday, we would have left the square root of 13. Okay. And it'll say in the directions, leave the square root as an exact answer or round. Okay. This one we're going to round. So square root of 13 to 3 decimal places would be
3.606.
3.606. Yep.
Now, is it always going to be 3 decimal places with these pretty much?
Yeah, we'll stick with 3. Unless the directions say 2, then we can do 2. Yeah. Okay. So that's C. All right, you pick what we do next. Alpha or beta, it doesn't matter.
Alpha.
Alpha. Okay. So let's find alpha. So what's the angle that I'm using this time?
We don't know.
Well, we don't know the number, but we know the name.
Alpha.
Yeah, we're doing alpha. So we really need a picture. Okay, let's see what's going on. Okay, how much is side A? 3. We always put that side here. How much is side B? 2. I'm not going to put side C in the picture because we didn't know that. What's the name of the angle across from A?
Opposite.
Well, yeah, alpha. And what's the name of the angle across from 2?
Beta.
Beta. That's a lousy beta. Okay, so there's our diagram. This is the hypotenuse. Okay. We're using alpha. That's our point of reference because that's the angle we're trying to find. So what position is the side that's 3 units long relative to alpha?
Adjacent.
No, not adjacent. Opposite.
Sorry.
And what's the side that's 2 units long?
Adjacent.
That's adjacent.
Didn't we get this wrong in the last question?
Did we what?
Did we get this wrong in the last question?
I don't think so. I don't think we have anything wrong.
Okay.
I think everything I put on the board so far is right. I hope. You can check the video now. So now you're trying to find alpha. And what's the position of the 2 sides that you know?
Opposite. Adjacent.
Opposite and adjacent. What trig function has opposite and adjacent?
Tangent.
Tangent.
Can I get the one?
Yeah. Okay. So tangent, leave room for your angle, and then put your fraction on the other side. What's my angle this time?
3/2.
Wait. That's alpha.
Alpha. And what's my fraction on the other side? 3/2.
That's what I was talking about.
So this is the first time that this has happened. Every problem we've done so far, it ended up with a letter on the fraction side, either in the top or in the bottom. This time, the letter is the argument to the trig function. It's the thing you're taking the tangent of. So, how can we get rid of tangent? We talked about that.
Nate. Inverse tangent.
Right, inverse tangent. And the way that you say it is the same way you'd say, it's the same word you would use when you describe how to solve that. To get rid of squaring, what do you use?
The inverse of it, square root.
And the inverse of it, which is square root. So the way you say that is you say take the square root of both sides. The way you say this one is take the inverse sign on both sides. So take the inverse sign of everything that's on the left and take the inverse sign of everything that's on the right. Now, what's going to happen with inverse tangent and regular tangent?
They're going to cancel.
Right, they're going to cancel. They only cancel, though, if this is between negative 90 and 90. Is this angle going to be between negative 90 and 90 when we solve it?
Yes.
Yeah, it has to be. It's an acute angle in a right triangle. It's definitely between negative 90 and 90. In fact, it's between 0 and 90. So, because we already know it's going to be in the range it's supposed to, those do cancel. And then we get alpha equals the inverse tangent of 3/2. So inverse tangent 3/2. What is that to 3 decimal places?
56.310.
Yeah, it's going to round up, so it's 56.310. Now, if we got that right, then the other answer should be 33.69. That's what it should be. Let's just keep that number in mind, 33.69, and see if we get that when we solve for beta the same way we did alpha. Okay, so now, find beta. Okay, we gotta be careful when we find beta. We are no longer using alpha as our reference point. It's like we're shifting and now we're walking to another spot in the triangle. What does that mean we need to do?
Change values.
Right. Those names don't apply anymore because you're at a different spot in the triangle. You're at beta. What's side 3 now?
Jason.
Oh, wait,
It's
sorry.
adjacent. And what's the side that's 2?
Opposite.
Now that's opposite. So you're still using opposite and adjacent, but they've switched. But because it's still opposite and adjacent, what trig function is it?
Tangent.
It's still, yeah, it's going to be tangent. Okay. What's the angle that I'm working with now? Beta. And what's going to be the fraction?
2 over 3.
Opposite over adjacent. 2 over 3.
When you have the two sides, is it just going to be tangent the entire time?
No, we could have had hypotenuse. And then it would have been sines.
Oh,
and
yeah.
cosines. Yeah. We just didn't have the hypotenuse this time.
Yep. Okay.
So beta is the inverse tangent of 2/3. Now we already know it should come out to 33.69. Let's see what we get. Inverse tangent of 2/3. We got exactly the same thing. So because I got the same answer subtracting it from 90 and doing it with inverse trig, I'm like 99% sure that it's right. So 33.690.
What's that other 1%?
I don't know. Who knows? Cosmic dust entered my calculator at the wrong time and caused a microcircuit to malfunction.
Oh.
I don't know. But yeah, we're pretty good. Okay. So, any questions on that one? That's the 2a. So, whenever you have the two sides to start with, and you have to find the two angles, you have to use inverse trig. Okay, that's the only time you need to use it. If I give you two sides, you need to use inverse trig. Question on that? Okay. Let me see. Let's try this one. All right, so it says that you're leaning on a 20-foot ladder against the house. The angle between the ladder and the house is 17 degrees. How high, basically, will the top of the ladder be on the house? Okay. Well, if it's a 20-foot ladder, so wouldn't the ladder just be 20 feet off the ground, the height of it?
No, because you're going to still be at an angle.
Yeah, it's going to be at an angle. So the more of an angle you put, the less high it's going to reach. Okay, so what do you think would be helpful with all that information?
Drawing a diagram.
Yeah, let's draw a diagram. What are we going to have in the diagram?
The hypotenuse being 20 feet, and one of the angles being 17 degrees, and the other angle being 90 degrees.
Okay, so how about, just, in fact, don't even worry about like mathy kind of stuff. Just think about the objects in the diagram.
A house.
Yeah, we need a house. And what else do we need?
Ladder.
A ladder, and you need one more kind of really important thing. The what? You need the ground.
Not ground. That's floating.
So there's the ground. Okay, we got our house. Let's put a house over here.
That house is not finishing during a storm. The storm should blow right over.
Yeah, it's gonna blow it over. So there's your house. And what else do we need?
A ladder.
Yeah, we need a ladder, and the ladder is leaning, against the house, something like that. All right, so now we've got all the objects in the problem. What can I label?
The 20 feet of the ladder.
Yeah, the ladder is 20 feet. It just jumped a little bit again. So the ladder is nowhere near the board. 20 feet from there to there.
You got 90, 17.
Yeah, so this,
I don't know that's going to be.
it should be. We're going to assume that the guy built the house. He did a really good job. And they didn't build it crooked like I did.
Oh, okay.
So we got a 90-degree angle. And what's, where's the 17 go?
Top.
At the top. It's not the angle between the ladder and the ground. It's the angle between the ladder and the house. So that is 17. So here's your triangle. And what are you trying to find in that triangle?
Alpha. You're trying to find the side that goes up against the house to see how high the ladder will reach.
Yeah, trying to find that.
Nice.
I mean, I called it X. I think we've been using A or B. What letter you use doesn't really matter. All right. So let's look at what we know and what we're trying to find. What's the position of the side that's given? Hypotenuse. What's the position of the side we want to know?
A.
So what's the position?
Adjacent.
It's adjacent. What trig function involves those two?
Cosine.
Cosine. Okay. What's the angle we're working with? 17 degrees. And what's the side that is adjacent to 17?
20.
A. A is adjacent. And what's the side that is the hypotenuse? 20. And what did you multiply by?
20.
Yep. Multiply each side by 20. That's gone. And that is where the top of the ladder will be. So 20 cosine 17. Okay. 19, well, you tell me the 3 decimal places.
19.130. Or 1.26.
19.126. Yep. We'll go
You went around the 6, right?
Nice into 3.
to 3. It'd be
Yeah.
126 because the 4th digit is a 0.
Okay.
If it was 1265 or higher, then it would be 127.
Yeah, I didn't know if you rounded the 6 for the 2. That's what I was asking. If you put it to make it to 1.13.
You could do 0.13 if it said to 2 decimal places, or
Oh, yeah,
126 to
Yeah,
3.
okay. Yeah.
So it's
That's the thing update.
and that's feet. So any questions on that? So I think that pretty much wraps up 4.2. Okay, so that's the homework for tonight. 31 to 39 odd, 43 and 47, and 51 to 55, that is also odd. So tomorrow we'll go over that. There'll be a review guide. I think I already put it on Schoology, but we'll do the review guide as much as we have time for in class. And whatever you don't finish on the review, that'll be the homework tomorrow. But if you finish everything, then no homework. And then we have our test on